You're listening to the Azure DevOps podcast, today featuring Sam Guckenheimer.
The Azure DevOps podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to another episode of the Azure DevOps podcast. Go online to www.azuredevops.show to see show notes and other episodes. I'm really excited today to speak with today's guest, Sam Guckenheimer. Sam is the product owner for the Azure DevOps product line at Microsoft. He has 30 years experience as an architect, developer, tester, product manager, project manager, general manager in the software industry worldwide. His first book, Software Engineering with Visual Studio, was translated into 7 languages and recognized as a de facto guide for teams adopting agile practices. A frequent speaker at industry conferences, Sam is a Phi Beta Kappa graduate of Harvard University, and he lives in Seattle with his wife and boasts 4 grown children raised in a sustainable house they built that's been featured in Metropolitan Home and Pacific Northwest magazine. Sam, welcome.
Hey, Jeffrey, how are you?
I'm good. How are you, sir?
I'm great, thank you.
So, big news there at Microsoft, and we'll get into that, but that's quite a bio. Out of all of that, what are you focusing on now?
Well, I'm now on the Azure DevOps team. I've been in Microsoft 15 years, as I think you read, and joined when we were just taking development from being about an IDE to being about working in teams. Over that decade and a half, it's evolved from being about developing and handing things off in a typically pretty manual process for operations to everyone working in a DevOps style, where you get rid of the silos, where you think of not a sprint producing a, quote, potentially shippable increment, but your work continually producing deployment into production in a seamless manner. And what I'm working on is the services and products that we have to make that possible.
Awesome. So with so many years at Microsoft and then Rational and IBM before then, you've seen quite a number of changes over the years. Which ones stand out in your mind?
Well, if you roll the clock back 20 years, that was probably the first point at which people got serious about software process.
Mm-hmm.
And they got way too serious. And we got into methodology wars, and you went through the whole agile period of more agile than thou and all that kind of stuff. I think today, folks just take it for granted that the way they need to work is by continually delivering working software. Now, for me, the things that stand out are the way the Agile movement initially said, you do not need all of this bureaucracy that is there in order to make sure you're doing the right thing. What you need is the discipline and teamwork to do the right thing. And then the way DevOps said, well, yes, and you not only need to do the right thing for creating software, it doesn't count until people are using it. So we went from a world where everyone was feeling great about producing what they thought was right. And in Agile, you had this notion that you did what the product owner said because the product owner was omniscient and figured out exactly what was right, to one in DevOps where you did what was actually used, and your definition of success was your measurement of how things were being used as they were being used, and it was continuous and disintermediated.
Okay. Well, I remember so many documents and different process elements that would sometimes take precedence to working software. So that certainly was a foundational element of the Agile Manifesto. What was that, 17 years ago now?
Yeah, 2001, April 2001.
Definitely a lot's changed. Well, now just the recent release of Azure DevOps services, so many things have come full circle. And of course, the announcements have gone out and everyone's jumping on board. What's the most exciting part of the overall Azure DevOps release for you?
I think the most exciting thing is the offer we're making around Azure Pipelines for open source teams. So if you have an open source project that is a public project on GitHub, you have in one service, Azure Pipelines, continuous integration and delivery for Linux, Mac OS, and Windows. You have unlimited build minutes. You have 10 parallel hosted pipelines, all at no charge. So
that's insane.
Yeah. So I think that this becomes something that every open source project needs to look at as a way to do continuous integration and delivery. Now, it's a continuation of the promise that we've made at Microsoft for the last 4 or 5 years of making open source great. I think we've gotten a lot of eyebrows raised, a lot of skepticism. Does Microsoft really mean it? What are they doing? By 2016, we were as a company, the top contributor to open source projects on GitHub. Now we're also giving all the other open source projects a fantastic jolt of infra and software and services that they can use to speed up their continuous integration and delivery.
Yeah, absolutely. I've been speaking to people and they're talking about the various projects that they're excited to get up and running on Azure DevOps services. Because if you think about the amount of capacity that's being offered for free, from a practical sense, it's unlimited. From a reasonable sense, how are most open source projects even going to use it all? And so it's just an amazing level.
Well, using it all is irrelevant.
Sure.
The thing that matters is that you remove all the impediments to getting from your contributions to your deliverable code.
Right.
And until now, people have had to use different build engines for different operating systems. They've had to put up with reduced qualities of service. They've had a high degree of complexity in getting to that continuous delivery of the code that they're working on. Now we hope we're removing a big impediment to that.
I'm sure that the numbers will continue to go up. We'll be able to see in the coming months just the number of open source projects that are taking advantage of that. That's pretty awesome. And it's pretty awesome to see that whether it's with the GitHub acquisition or just Git in general, the amount of open source frameworks that Microsoft has put out to the world even.
Yeah, again, I'm cautious to say the number is so important as it is the extent to which everything you do is now available to you to improve. So if I'm using Node, what matters to me is that I can contribute to making Node better. If I'm using .NET Core, I can contribute to making that better. If I'm using Golang, I can contribute to that. And I can keep up with the velocity of improvement by continually leaning to latest. And I can do that with their, as a project, having a great pipeline, and me or my team as a consumer having a great pipeline, so that I can validate that everything is current, so that I don't have any particular delay in taking updates, so that I can always produce latest for my stuff, and I can deliver many times a day. That's where it matters.
Right. Okay. Well, there's also been a lot of transition, a lot of learning at Microsoft, going through a transition to adopting DevOps in a lot of different departments. And you guys have learned a lot about what actually makes DevOps successful.
Yeah, we run the service that is now used by 80-some thousand engineers here at Microsoft, day in, day out. So and they're using the same Azure DevOps that we offer to customers, running on the same Azure cloud. There's not a difference in the quality of service we provide internally or externally. So we basically are using Microsoft as our largest and in some ways most demanding customer to improve Azure DevOps for everyone. We think that the biggest change in how you work is that you think about done very differently. So going back to our earlier chat about Agile, and Agile helpfully introduced the idea of a definition of done.
Mm-hmm.
And there was a lot of debate for several years about what done meant. Well, for us, done means code running in production, code delivered with tests, and with telemetry, so that in production, you can tell whether the deployment that you made is substantiating or diminishing hypothesis that led to its deployment. So in other words, you can actually see now, well, is this improving performance? Is this increasing usage? Is this increasing the amount of time people are spending on page if you're an engagement style app? Or is it reducing the amount of time people need to do something if you're a tool like we are? Is it having the impact on repeated usage? Is it creating higher customer satisfaction, which you can measure with things like Net Promoter Score? Are all of these end effects that you hope to achieve moving in the right direction because of what you're doing? And that was something we never could do before. In the days when we shipped box software and customers installed it, you would, and things took months or years, your feedback cycles were completely broken because they were too long, and you didn't have any real direct way of measuring anything. So you were doing all of this stuff off of, surveys. Well, do you remember over the last 6 months, And now we actually know a bunch of stuff.
Mm-hmm.
We know how long it takes for a page to load to get to interactive. We know how many people become engaged users and how many drop out. We know how the quality of service is for you as an end user because we have the instrumentation. We know if there's a live site incident, what is triggering the problem, and we know how to troubleshoot and what we need to do for deep remediation. It's a whole different world.
The Azure DevOps podcast is sponsored by ClearMeasure, a software engineering firm and Microsoft Gold partner, empowering development teams to be their best. ClearMeasure equips developers with the DevOps tools, methods, and automation necessary to focus on building their applications, rather than wrestling with builds, deployments, or environments. Click clear-measure.com to see whether a DevOps implementation is for you.
Yeah. You brought up a really interesting point. My wife used to be a sixth grade science teacher, and the scientific method comes to mind when you talked about what we thought would happen if we prioritize feature A or make change B and put it in production. It's not that, hey, it was definitely a good idea to do that, but we think that it's a good idea to do this, but now we need to make sure.
Yeah, well, we have a lot of research. Ronnie Kohavi, who's a technical fellow here at Microsoft, did a lot of research in the last decade on how good we professional engineering teams, how good we are at predicting the impact that our changes will have on user interaction and behavior. And the simple way of describing his findings is to say that there's a rule of thirds. A third of the time, the changes you make get the results you want with positive effect. A third of the time, they have negative effect. In other words, you thought that by doing these changes on your web page, you would get people to click through more or to be engaged more or whatever. And you get the opposite effect. In other words, the change turns them off. And a third of the time, it makes no difference. So if you apply Ronnie's rules of thirds and say, what does that mean for how I work? It means that I need to have as short a feedback cycle as I can in order to determine whether the action I took is in the positive third or the neutral to negative 2/3. And I need to double down if it's in the positive third, and I need to pivot if it's in the other 2/3. So what matters is not, how big a change you make. What matters is how frequently you can get that direct feedback in order to determine, is this right? Is this going in the right direction? Or do I pivot and do something else? And you need to create that virtuous feedback cycle with as short a loop as you can. And that's the big learning of working in a DevOps world. That's the big learning of experimentation, is that you get that direct feedback loop and you can start to make data-informed decisions. That's the most important change. Going back to Agile, our notion was, well, you have a product backlog, you have a product owner who prioritizes it, and you peel stuff off the backlog. Now, what you're saying is, well, we have a backlog, but those aren't requirement-like things, those user stories. Those are hypotheses. We believe that if we do X, it will have good outcome Y. And your goal is not to keep piling on the beliefs. Your goal is to get the experiments to tell you what actual Y you got from X. And based on that information, make the decision about the next step.
Mm-hmm. With this going far beyond just operating and monitoring tools, for people using Azure DevOps services, what are some of the good practices that you guys have learned when it comes to gathering that live site telemetry and the information by which you can learn the answer?
What we do is that we have rather strict conventions around instrumentation, and we have a very wide pipeline around data collection. So we use what customers would know as Azure Log Analytics and Azure Application Insights as that pipeline. And we log everything that happens as a user interacts with the service. So if we need to collect data for troubleshooting, the data is already collected and it's a matter of querying it. And because the pipeline is so fast, it's available, and the querying can happen in essentially near real time. So, you get the results back before you actually try to query them. It's you're measuring things in seconds, not hours or days. And at the same time, we distill that data to get information about usage patterns and trends and all that sort of stuff. So having that telemetry pipe is absolutely essential. Having great conventions about how you log into that is really helpful. I've posted some articles about this on my DevOps and Microsoft site. You can get there with the link aka.ms/DevOps. And under DevOps at Microsoft, you can see articles about how we work. I know you've talked to my friend Buck Hodges. He's done some talks there, as have others. And there's an article with a video about this very topic of going to the cloud and putting in appropriate telemetry.
Okay. Yeah, we'll put that in the show notes. Are there any other internal learnings that come to mind?
Yeah, totally. So the whole idea of what we call here a live site culture, or a production first mindset, or service reliability engineering is, I think, the industry's snapping to now. That's all new. The notion that instead of having, separate ops teams that are removed and go through escalation, you put dev and ops together, and everyone in engineering rotates with responsibility for live site. So we here call this DRI, designated responsible individual, and you're, as an engineer, on call as DRI on a rotation, maybe a week, a quarter. When you're DRI, if there's a live site incident, you are expected to be on the bridge with access to the code in 5 minutes if it's working hours, and if it's outside of working hours, say middle of the night, within 15 minutes. And if it is the middle of the night and you're DRI and you're paged, the voice on the phone waking you up is Satya's.
Okay.
It's a recording,
Literally.
but it's Satya.
Okay.
And the not so subtle hint is we take this seriously. So
yeah.
The net effect of that is you have experience of having to deal with issues in the fog of war. And if you can't troubleshoot this, you say, we're missing some telemetry here. Or you look and you say, why did this happen? We're missing testing here. You say, we need to get better tests. Or, there's some error handling that should have happened. We need to fix that. And all of these things that answer the question, what do we need to do in order to prevent the recurrence? What do we do so that this doesn't happen next time? Those all go down as repair items for the live site incident. And you do not get to close the LSI until you've captured the repair items, and those go on the backlog so that you can close them in preferably one sprint. And if they go over 2 sprints, you get this red warning, and you stop doing new work and you fix your repair items. So it's really this idea of prioritizing what it takes for live site health is something we do very seriously. And I'm sure you've seen that every time we do have an outage, and like everyone, we do have outages, that an outage that does affect customers, we share that analysis in public. We blog about it. We say, here's what happened. Here's what we're doing to prevent recurrence. And we make those specific learnings public. And that creates a sort of implicit contract with our customers that we're going to fix those things and not let them happen again.
So when the industry was learning about test-driven development and all kinds of automated testing, there were certain architectural or design elements that either helped or hurt the testability of a system. And of course, those changes were made. Have you found any architectural or design decisions or patterns that help or hurt the live site supportability of a complex system?
Well, it's similar to the testability question. You need things to be loosely coupled with clear interfaces, and you need services to have minimal dependencies and no opaque dependencies. So the notion of observability has become widely talked about in this regard. I don't think that the requirements of observability are that different than the requirements of good testability. I think and I actually think it's not that different from what people have talked about in the past with regard to loose coupling. But because the feedback loop is so short now, you get really clear evidence whether you're doing it. In other words, the test of good architecture is not a diagram on a whiteboard. It's your ability to troubleshoot in production. And and the consequence of your creating dependencies that shouldn't be there is not that it's hard to debug and slower to make changes for the next blah, blah release. The consequence is that what ought to be a transient error that's handled by, a pattern in the service, like, throttling or circuit breaker or something like that, turns into a cascading fault. That is a really big difference. So I think observability is very important, and the way testability is very important. I think that and of course we do telemetry now the way in a way we couldn't before, both because we're running live and because we have these great pipelines for handling high volume data. For Azure, it's I think 5 petabytes a day across Azure services now that get ingested live. And that volume of data wasn't possible before, but the knowledge was largely there before. The conventions have evolved, so people now isolate their services behind RESTful APIs, frequently in containers, to enforce that loose coupling.
Yeah. And of course, you still have a lot of traditional monitoring tools, or at least the methods, the APM tools out there that they work a certain way. And when you package up each of the services with APIs, then it enables a lot of those tools to just light up and work automatically.
Yeah, I think there are lots of great APM tools. And I think that the market has matured very fast. I think that they are, on the whole, doing a really good job allowing data collection. I think that they're creating the challenge that we and everyone else have of going from all of this data collection to intelligent alerting. So again, it doesn't really matter when push comes to shove what volume of data you collect. What matters is that you collect the right stuff you need when there's an incident,
Right.
and you get the right trends that you need for analysis. So, which reminds me a lot of the 20-year-old joke. How much testing do you need? Well, just the only tests you need are the ones that find bugs.
Right. So which ones are they?
Right, exactly. So in both cases, you reason and you say, well, we need to measure everything. We need to test everything. And we need a good mechanism for sifting the bugs out or sifting the live site incidents out, and getting the alerts that are meaningful.
Yeah, definitely. Well, you guys have published so much in a written form, video form, what's going on with DevOps at Microsoft. But there's also an industry-wide State of DevOps report that's been pretty interesting.
The State of DevOps report is fantastic this year. I had the good fortune to advise on it with the researchers, Nicole Forsgren and Jez Humble and Gene Kim. And I really think that this is the best empirical study of what is working for people delivering software that I've seen in my career. The thing that really pops out for me is that the report identifies a causal model backed up by their data of what makes people successful. And they identify the positive impacts of continuous delivery, appropriate culture, the use of cloud infrastructure on software delivery and operational performance. And they go further and then break out what goes into effective continuous delivery. So they look at it not just as continuous integration, not just as deployment automation, but talk about development practices like doing trunk-based development or a single master to use Git terms, doing loosely coupled services like we just talked about, applying version control with a pull request flow so that you can manage the changes, testing in the pipeline continuously, putting in the monitoring and observability, managing the database changes with code, managing security in the pipeline so that it's not an afterthought activity, but something that goes in continuously at the beginning. All of these very real practices, they observe and measure, and they can determine, because they have sufficient data, what has positive or negative impact on results. So, for example, if you do functional outsourcing, that is, if you send your testing to another firm in another continent, it will have a negative impact.
Nice and clear.
And they can, substantiate that with data, and they can differentiate among categories of performance. What they call, they used to just do high, medium, low. Now they talk about elite, high, medium, low, and misguided performers. And they have effectively clustered the outcomes with regard to those organizational impacts, and they can then observe this in frequency of delivery and in quality of service measured by frequency of incidents and time to recover. They can look at this in terms of employee morale and customer satisfaction. It's a beautiful piece of work.
Awesome. That's fantastic. And as we wrap up, for those listening out there, and I would say most of the data shows that most software teams are smaller software teams. What rules of thumb can they take away from the State of DevOps report or the internal learnings that you guys have learned for yourselves? And what rules of thumb could they apply as they continue their use of Azure DevOps services and just their custom software in general in order to get better at running their own systems?
Well, it starts with where you are and what you're doing today. If you are not doing continuous integration, for example, you better start. If you're not doing continuous testing, that's one of the next things to add. And safe deployment practices for continuous delivery. And a lot of it revolves around that good continuous delivery pipeline. However, we've touched on monitoring as part of it. We've touched on source control practices, working from a single master, having control over changes before they get to master through a pull request flow, how you manage your backlog. These all contribute to effective delivery. And what typically happens in a well-functioning team is you tackle the next biggest bottleneck, take care of that, and then once you've opened that bottleneck, another one becomes the next biggest. And so you do this continual prioritization of effectively fixing the problem that creates the biggest impediment. And when you've done that, going to the next biggest, and so on, and going down the practices in that way. And that's frankly why we try to share so much information online to make it easy for people to say, well, we got that one down. Now what do we do about testing? What do we do about safe deployment? What do we do about live site visibility? And we try to let someone see not just, this is a good thing to do, but here is an example of how we do it, how someone like us does it, so that there's an example and people can say, yeah, well, we could do that, or we do that with a slight change, what have you. And one of the other great things about the State of DevOps report is that it does also show that this is a journey, and you get better initially, and then when you hit the next problem, like you discover, all this automation exposes we don't have enough testing, you then kind of go through a dip while you pay off that technical debt. And then you go better, get better again. They call it a J curve because of the shape. And it's a very clever observation that very much matches reality. I mean, we've been at this DevOps journey here for 8 years. We would say we're, far short of halfway. But we always get better, and we measure ourselves all the time on how much better we've gotten. And what's next?
Fantastic. Well, that was a lot of great information. We're going to have all that in the show notes, links, and other resources, because we covered quite a lot. But thanks so much, Sam, for visiting with me.
It's a great pleasure, Jeffrey. I look forward to seeing you again soon.
Awesome. And until next week, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.